No one knows how much time we have to listen to the universe, but if you are still here, send back a little signal. Let the universe know that you are still awake with it. July 2025. In the long, windless nights of the southern hemisphere, a strange point of light appeared in humanity's data. No one knew where it came from. They only knew it did not belong here. It had no stable orbit, no obedience to the pull of the sun, and moved so swiftly that every existing model had to be recalculated. It crossed the void, carrying ancient signals, as if it had drifted from another era of the cosmos. No one could see its shape, only its light. The light of a distant visitor passing quietly through the small sky that humankind calls home. From that moment, the silence of the universe was broken. Observatories across the world turned toward a single coordinate. Streams of data began to pour in, and every system, every sensor, every voice spoke the same truth. An object from beyond the solar system was crossing the space around Earth. They say the universe never sends the same signal twice, and when a strange light appears, humanity has only two choices: to ignore it or to stop and listen. The scientists chose the latter. They gave the light a name: 3I Atlas, the third interstellar object ever discovered by humankind, a traveler crossing the boundary between stars, leaving behind a faint trail in the data of our fragile world. From the moment its name was spoken, something in the scientific atmosphere shifted. No one said it aloud, but everyone sensed that this orbit was different, a motion that did not belong to the solar system, a trajectory too deliberate to be called coincidence. If you are still listening, and this story is unfolding somewhere in your mind, leave a small trace, a comment, a like, so I'll know you're still awake, still looking toward that light with me. Astronomers widened their reach. From South America to Hawaii, from South Africa to Europe, observatories turned their lenses toward a single point in the night sky, and with every new frame, every captured signal, the truth grew sharper, undeniable. The object was approaching, and it did not come from any place we have ever known. Before the name 3I Atlas was entered into the astronomical catalog, humanity had known only two visitors from the distant unknown: Oumuamua in 2017 and Borisov in 2019. Those two objects forced the world to re-examine what interstellar truly meant. Oumuamua passed without a comet's tail, only with shifting reflections of light, so peculiar that scientists argued for years about its true shape and origin. Borisov, on the other hand, was unmistakably a comet, its long icy tail shimmering behind it, carrying chemical signatures unlike anything found within our solar system. And then, in 2025, came 3I Atlas. It was neither as strange in form as Oumuamua, nor as classically comet-like as Borisov. It existed between two worlds, a point of intersection where science had no words yet to define what it was. As the great telescopes began to record its signal, all data converged toward one fact: this object was moving faster than any other that had ever passed through the solar system, 58 kilometers per second, so fast that even the sun's gravity could only bend its path, but never hold it. If 3I Atlas could not be captured, then it came from somewhere else, and would soon leave again, carrying our story into the distance, where even light begins to fade. Some said 3i Atlas was a message from the past, a fragment left over from when the universe was young, still holding the untouched elements of creation. But others believed something more haunting, that we are not the first beings to see it. Perhaps, somewhere in a civilization long vanished, someone once watched it too, just as we do now. If that thought stirs both curiosity and unease within you, leave a small sign, a comment, a whisper, so I know you are still here, still listening, still wondering with me. Compared to Oumuamua, 3i Atlas offered a far clearer view. Technology had advanced, and experience from the two earlier encounters made the scientific community careful not to miss a single detail. Every spectral band was recorded, every orbital deviation calculated. Everyone knew opportunities like this might come only once in a lifetime. When the first reflected light from its surface was detected, scientists immediately sensed its difference. It was surrounded by a veil of dust, but not as luminous as a typical comet. It released faint gases, yet unevenly, as if the object itself were learning to breathe in space. Researchers turned to questions of origin. Perhaps it came from a star system that collapsed billions of years ago, or from the debris of a planetary collision in some remote corner of the galaxy. Some suggested it carried elements unknown to the chemistry of our solar system. And then, a quiet theory began to take form. If 3i Atlas truly came from another world, might it also carry a story, a memory of where it came from, a material record, a cosmic echo, a fragment of the universe's ancient past, still drifting between the stars? When the first news broadcasts aired, the phrase, "the third interstellar object," spread everywhere, through headlines, scientific forums, and small channels run by skywatchers who stayed up through the night. They spoke of 3i Atlas not merely as a discovery, but as a reminder that the universe is still speaking to us in ways we do not yet know how to understand. And in the stillness of space, it seemed that something faint was resonating, a sound beyond instruments, but felt by all who listened, a sense that we were standing before something vast, something beyond numbers, equations, or models, something that quietly asked us to remember how small and how extraordinary we truly are. When news of 3i Atlas broke, the atmosphere in the scientific world ignited. Within days, from small observatories to vast space agencies, one name was on every screen, every voice channel, every late-night meeting. In July, there had been only 4 papers, tiny sparks within the endless sea of astronomical data. But by September, there were nearly 70. A true fever swept across the global astronomy community. Research teams everywhere began running orbital simulations. Telescopes were reoriented toward the coordinates, where 3i Atlas would soon glide across the sky. Boundaries dissolved. Americans, Europeans, Japanese, all eyes turned toward the same moving point of light amid the dark. Some teams even opened their data portals to the public, allowing anyone in the world to follow the interstellar traveler's path in real time. In the quiet of online conferences, only the faint clicks of keyboards and the hum of computers could be heard. There was no excitement, no grandstanding, just focus. Everyone understood one simple truth. Objects like 3i Atlas do not wait. They pass through once, and when they leave, they never return. Amid this storm of research, something subtle happened. Astronomers began to collaborate in ways rarely seen before. Projects that had long operated separately began sharing data, weaving a global network of observation, a web stretched across time zones, from east to west, day to night, all working to keep that small, drifting light from slipping out of sight. Some said this was a rare, crystalline moment for science, a time without debate, without ego or power, only the shared hunger to understand. From that spirit, a new phrase emerged: the interstellar hunt. It was not about possession or control, but about listening to the cosmos, to the faint visitors who cross our system unseen, to ask whether, in the infinite sea above us, there are others like 3I Atlas, wandering, silent, passing close by without ever being noticed. As October approached, all attention turned to a single date. The day 3I Atlas would reach its closest point to the Sunday. That moment, called perihelion, would be humanity's final chance to see the interstellar traveler clearly, before it slipped beyond sight, back into the quiet dark from which it came. According to predictions, 3I Atlas would make its closest approach to the Sun in late October 2025. The distance was estimated to be about 1.4 astronomical units, closer than the gap between Earth and Mars. But that closeness came with a cost. The Sun's glare was too fierce, its surrounding heat too violent, for any ground-based instrument to track the object stably. Observatories would have to wait for it to pass through the blinding light and emerge again on the far side of its orbit. For most telescopes, this became a moment of observational blindness. The universe went quiet. No images, no signals, only equations and hope. Scientists began simulating its path through the period of silence. Would 3I Atlas disintegrate under the Sun's brutal radiation, or would it survive, emerging intact, continuing its voyage into the darker regions beyond? In those models, one curious pattern kept reappearing. Though details varied, every simulation revealed the same anomaly. 3I Atlas did not move exactly as gravity predicted. There was a faint deviation, as if some invisible hand were quietly guiding its motion. A tiny oscillation, but undeniably real. Some researchers dismissed it as statistical noise. Others proposed that the object might carry a self-regulating energy field, a kind of breathing system for matter at interstellar scale. No theory fit perfectly, but everyone agreed on one thing: we did not yet understand what was passing above us. As October 30th approached, the world seemed to hold its breath, not out of fear, but from the rare awareness of witnessing something that does not belong to us, an emissary from elsewhere, passing briefly through our solar system before returning to the eternal dark. No one knew if we would ever see it again. No one could be sure that this would be the last interstellar visitor, yet everyone felt something quietly profound, that even across hundreds of millions of kilometers, the object had somehow connected us. In the silent stream of data from the observatories, the light of 3I Atlas slowly faded until it vanished from every frame. Nothing left to see, only waiting. And in that waiting, humanity glimpsed its true limits. We can calculate, analyze, predict, but we remain small beings, still learning to listen to the universe, with ears not yet fully formed. On the final night of October, some astronomers stayed awake. not to observe, but simply to feel. Because sometimes, to hear the universe speak, even once, is privilege enough. When 3I Atlas slipped beyond the range of human sight, the universe returned to silence. No more light, no more image, only faint data lines fading across the monitors. But for scientists, that was not an ending. It was the beginning of another kind of journey, a journey through silence. No longer did telescopes turn upward toward the sky. Now, thousands of servers turned backward in time, downloading every fragment of recorded signal from the brief weeks before the object vanished. From Hawaii, South Africa, Chile, Arizona, and dozens of space observatories, data archives were awakened. Everyone knew what remained of 3I Atlas now existed only in numbers. In decades of astronomy, such unity had rarely been seen. Institutions that once worked in isolation now shared their findings freely, forming a network that circled the globe. It became a new kind of pursuit, a hunt through data. From NASA to ESA to JAXA, researchers combed through old observations, faint images, weak readings. Every incomplete line of code was remapped onto the path of 3I Atlas. Every signal, no matter how small, might hold a key. Within 2 months, millions of data packets had been exchanged among research centers. A scientist in France described the feeling simply: "We can no longer see it, but its data is still alive." As walk. On the screens, spectral bands stretched like ocean waves, sometimes broken, sometimes missing. Yet everyone believed those gaps meant something. When NASA released the first light curve sequence, a detail drew instant attention. 3I Atlas showed a rhythmic variation, a steady cycle repeating every 8 hours. It wasn't a rotation, nor a conventional physical oscillation. It was something else. Some said it was natural, caused by the sublimation of volatile compounds. Others argued it was too consistent, too deliberate, as though the object had a pattern of its own. Closed-door meetings multiplied. Simulations were rebuilt. A neural network was trained to learn the cadence of the light, but no answer fit. Then came a single word from a Harvard research paper: breath. From that, the phrase spread across the scientific world. The object that breathes. No one could confirm it, but everyone felt its strangeness. As if the universe itself were alive, and 3I Atlas was simply one inhale in its endless respiration. Old data was reopened everywhere. Amateur observatories joined the search. Faint images from June, once dismissed, were re-examined, pixel by pixel. Some discovered they had captured the object long before it was even announced. That realization was uncanny, a reminder that humanity had already seen it, yet had not recognized what it was. The fever spread. Thousands combed through archives, hunting for forgotten traces. Some found frames where the object should have appeared, and yet nothing. No light, no form, only darkness. No one knew whether it was an error or a genuine transformation, but what lingered most was not confusion. It was wonder, the sense that the universe still guards its secret chambers just beyond our reach. Amid that ocean of data, science became something quieter, almost meditative. Every sequence of numbers became a form of listening to what is unseen, listening to an object that has left, but still hums faintly, in the light it once reflected. And as the nights passed, a new understanding began to form. 3I Atlas was not merely an object. It was an event, a lesson in how humanity learns to observe, to interpret, to wait, and in the stillness between signals, we began to realize, to understand the cosmos, we must learn to see with patience and to believe that even silence has meaning. As research teams on Earth began to run out of new data, human eyes turned outward, toward space. In Earth's orbit, telescopes like Hubble and James Webb were reactivated under emergency observation mode. Every hour, new data requests were sent. And then, part of the picture began to emerge. Hubble captured the first images in late July. In the photos, 3I Atlas was no longer a faint dot of light, but took on the shape of a teardrop, one end bright, the other trailing off like vapor. The solid nucleus inside was much smaller than expected, only a few hundred meters across, but the surrounding layer, a halo of gas and dust, glowed tens of times brighter. Researchers realized that what they once thought was a solid object was in fact the light from gas slowly evaporating away. When NASA released those images, a wave of commentary swept through the global scientific network. No one spoke about collision risks anymore. Only pure astonishment remained. One researcher wrote, "It's strange. The object looks like a droplet of water suspended in a vacuum, yet it seems to carry the history of an entire galaxy within it. Is for selfly and sluters pretend as sluters and why friend of, into never sluters for fluggen with relows that called of sluters then sluters, and we starge the ninders and wya from the strunglies, and there starge to these sluters from ovov. This now is that called us, and the wya from rum, the sluters, and the wya from." James Webb, with its infrared vision, turned its instruments to the same coordinates. On August 6, the first spectral signals were recorded. The surface of 3I Atlas emitted strong CO and CO2, while water vapor, a common component of comets, was almost entirely absent. No one expected a cold object from deep space to release so much carbon gas. In some of the infrared frames, its dust particles appeared to drift toward the sun, as if the pressure of CO2 gas was pushing them backward against gravity. From there, new questions began to arise. Could this be a self-regulating material structure? Did its surface possess its own balancing mechanism? Or was it simply coincidence? A strange physical phenomenon humanity had never witnessed before. The deeper the research went, the more scientists realized that each new question born from data only led into darker, uncharted regions. And sometimes, that silence itself was more alluring than any answer. If you are still listening, try to imagine how they must have felt. A small object, no larger than an island, flying hundreds of millions of kilometers away, yet every photon reflected from it was enough to keep people awake through the night, just to find out why it exists. TESS, the planet-hunting satellite, unexpectedly provided another crucial piece. Its archives revealed that the object had already appeared in its field of view. As early as May, 2 months before its official discovery, its brightness had increased fivefold within just a few weeks, a phenomenon no one could explain. That meant 3I Atlas had been highly active, even when it was 6 astronomical units away from the Sunday. The first models were built, based on the outgassing of supervolatile substances, nitrogen, hydrogen, and CO2. Some hypotheses suggested It might have a structure similar to comets, originating from the cold outer edge of the universe, where sunlight rarely reaches. But what astonished researchers most was the stability of its light emission. Though its brightness surged, its intensity fluctuated only within a narrow range, as if there were an invisible mechanism regulating its internal energy. From the data of Hubble, James Webb, and TESS, a unified picture gradually took shape. 3I Atlas was a highly active object, erupting carbon compounds, shining steadily over long periods and seemingly self-regulating. Physicists began to question the nature of its internal energy, not the kind of energy we understand, but a type capable of maintaining thermal balance across billions of kilometers of absolute cold. A team at the Max Planck Institute modeled this phenomenon with the concept of a self-restoring energy field. According to their hypothesis, some ancient interstellar objects might possess self-stabilizing energy oscillations that allow them to persist for billions of years. Although unproven, the idea spread quickly, for it opened an entirely new way of thinking, that in the universe, some objects might not only exist, but know how to keep existing. The scientific community named it the living field effect, a vague term, but powerful enough to ignite imaginations worldwide. Somewhere, among thousands of reports, people began to realize that 3I Atlas was not just the story of an object in motion. It was the story of how humanity was learning to see the universe as something alive. And across every report, whether in offices or observatories in the desert, a shared feeling spread that perhaps we are not merely studying the universe, but being allowed by it to see a small part of itself. As the orbital satellites continued to transmit streams of infrared data, the telescopes on Earth entered their next phase, close-range observation. The southern skies, especially above Cerro Pachón in Chile, became the point where every lens turned toward a single spot. On the 27th of August, 2025, the Gemini South Telescope captured the most detailed image yet of 3I Atlas. Under a faint bluish glow, the object appeared sharper than ever before. A structure with a long, widening tail, stretching nearly 10,000 kilometers across. What astonished researchers was not the length, but the form. Unlike a comet's diffuse spray, 3I Atlas's tail seemed structured. Fine streams of material overlapped one another, forming alternating bright and dark bands, as if some internal rhythm were orchestrating the motion of dust and gas. In its spectral data, the team found something unexpected: CN emission lines. Cyanide, a toxic compound, but one that typically appears when comets sublimate water and release hydrogen cyanide. That meant 3I Atlas might contain frozen water, or something chemically similar, which, under sunlight, was breaking apart and leaving cyanide trails in space. The emission rate was estimated at 8 times 10 to the power of 23 molecules per second, close to the upper limit for the most active comets. But 3I Atlas was no ordinary comet. It still showed unusually low levels of carbon, much like the interstellar object Borisov in 2019. This led researchers to suspect it may have formed in an environment far colder than the edge of any known stellar system. Measurements revealed that the tail's composition was not just gas and dust, but also lightly ionized material, indicating interaction with the solar wind. Weak electromagnetic currents swept through the dust, producing faint, rhythmic pulses of light. Many began calling it the heartbeat of the object. Each new image released left the world silent for a few seconds. Before the inevitable wave of awe, there was something both beautiful and unsettling about it, a reminder that humanity was witnessing something born far from life, yet behaving as though it were alive. If you are listening, try to picture it. A dim glowing streak, its tail stretching deep into space, and within it, billions of tiny dust grains reflecting sunlight, like scattered memories of the universe, carried away on the wind. The Gemini team sent their data to NASA headquarters in Pasadena. Initial analysis confirmed what they had seen was real. 3I Atlas was venting gas violently, but irregularly. Its emission intensity fluctuated in 8-hour cycles, matching the breathing pattern previously detected. Plasma physicists from ESA joined the investigation. They noted that the cyanide gas pressure was rising in the opposite direction of solar radiation. That explained why the tail did not fan outward evenly, but bent backward, as though part of the gas was being pushed against the light itself. No such phenomenon had ever been recorded in cometary history. It resembled a natural propulsion mechanism, a way for an object to adjust its own trajectory, using its internal energy. Physicists tentatively named it the interstellar back pressure effect. In theory, it could allow an object to sustain a stable path through space without being fully governed by gravity. If that was true, then 3I Atlas was demonstrating a form of motion never before confirmed in nature. Not passive orbit, but directed travel. That realization made many researchers pause, because if the object could truly maintain its own course, then the next question was unavoidable. Was it natural, or was it made? No one rushed to answer. No one dared make claims among billions of data points, but in the quiet rooms filled with monitors and hundreds of glowing images, a shared awareness took hold. 3I Atlas was no longer just a discovery, it had become a mystery. From that moment on, every telescope on Earth turned toward it. No more borders, no more proprietary data. Only one question echoed in the collective mind of humankind. What are we looking at? While chemical composition and tail structure data were still being decoded, a small team at the University of Cape Town, led by Dr. Zuri Gray, chose a different path of inquiry. They did not look at the object. They looked at how its light reflected. On the 5th of September 2025, Gray's team published the first polarimetric measurements of 3I Atlas. The initial numbers made them double-check their instruments repeatedly because the results resembled nothing ever recorded from any comet before. Ordinarily, light scattered by cometary dust exhibits positive polarization, meaning the light waves spread naturally in slightly offset directions. But here, 3I Atlas showed a narrow, deep band of negative polarization confined to a very small range of scattering angles. It wasn't merely different. It behaved in direct opposition to every known optical pattern in planetary science. After multiple cross-checks, the team confirmed the data were genuine. Light from 3I Atlas did not scatter normally. Instead of dispersing evenly, it seemed to focus as if the surface dust grains of the object were arranged in some special microscopic order. Astronomers labeled this effect a negative polarization anomaly, a rare signature usually seen only on ultra-smooth surfaces or in materials with unusual optical properties. The findings startled everyone. If 3I Atlas were just a classical comet, its surface should be chaotic, a mix of dust and gas reflecting light randomly. Yet the data showed the opposite, a level of uniformity almost impossible to explain. Researchers began comparing its polarization curve to objects on the outer rim of the solar system. icy bodies like centaurs and trans-Neptunian objects. Some, such as Chariklo or Haumea, had displayed similar odd polarization once before, but never this deep and never this stable. That hinted that 3I Atlas might contain matter, similar to ancient crystalline ices, formed under conditions of near absolute zero temperature and pressure. Its structure might not just be ice and dust, but a crystal lattice of carbon, nitrogen, and compounds capable of directing light in precise ways. Another hypothesis proposed that the surface could be optically compressed, an effect that occurs when tiny particles align in weak electromagnetic fields, forcing reflected light to move in the same direction. If true, 3I Atlas would not only maintain thermal equilibrium, but also display an internal organization at the microscopic level. No one said it aloud, but the notion of such order evoked an unsettling association with design, not in the sense of artificial creation, but of self-organizing systems, structures, nature builds, not merely to exist, but to preserve the act of existing. Gray's report spread rapidly through the scientific community. Other observatories raced to verify it. From Spain, Japan, and Chile, polarimetric instruments locked onto the same coordinates, and every result repeated the same pattern. 3I Atlas exhibited deeper negative polarization than any object ever measured. It became a complete outlier in humanity's optical database. At a meeting of the International Astronomical Union, one scientist quietly remarked, "Perhaps we're seeing light from an object that existed before the Milky Way itself was born." No one replied. The sentence drifted in the air, a truth too vast to confirm and too elegant to deny. From that moment on, every observation of 3I Atlas was labeled anomaly, not merely because of the data, but because it altered human awareness itself. Sometimes, what we fail to understand does not lie within the object, but within the limits of our own perception. At that point, science ceased to be the pursuit of answers and became the quiet art of accepting the things we cannot yet explain. When the first reports of 3I Atlas spread through the scientific community, somewhere inside a quiet NASA office, a small research team quietly submitted a request for emergency observation time on the Hubble Space Telescope. It was a rare request. Hubble's schedule was planned months in advance, and every minute of observation was worth hundreds of thousands of dollars. But this time was different. No one wanted to wait. The object was racing through space at nearly 60 kilometers per second, and within just a few days, it would leave the optimal window of observation. The request was approved almost immediately. A small gap was opened in Hubble's packed schedule, and on the 21st of July 2025, Hubble turned its lens toward the coordinates where 3I Atlas was moving. No one on the team knew what they were about to see. When the first frames were transmitted down to Earth, the control room fell completely silent. A faint dot appeared against the black background, and slowly, layer by layer, the image sharpened. It wasn't round. It wasn't elliptical. It didn't resemble any comet known to science. 3I Atlas took the shape of a teardrop, one end swollen with light, the other stretched backward, as if pulled apart by its own velocity. It was the first time humanity had truly seen it, no longer just a column of uncertain numbers, but an image distinct, real, and hauntingly beautiful. The nucleus, the region of strongest reflection, was smaller than any earlier predictions, somewhere between 440 meters and 5.6 kilometers across, instead of the 10 kilometers once modeled. That meant most of its luminosity, did not come from solid matter, but from the surrounding coma, a halo of gas and dust. And that halo was not chaotic. It had direction, texture, and rhythm, moving as if in synchronization with the nucleus at its center. Some specialists described it as an energy shell, where sunlight was not merely reflected, but subtly modulated by the object's own internal oscillations. When the images were processed at higher resolution, the bright rim appeared slightly curved, like a faint crescent. No one could explain the geometry, but it looked as though the object was passing through a layer of denser space, like a pebble skimming across the surface of a pond, leaving ripples behind it. In NASA's internal briefings, the image was summarized with a single phrase: "It's alive." Not in a biological sense, but in the sense that it moved with a complexity no lifeless rock or ice ever had. Further frames were taken over a 6-hour window. During that brief period, the central brightness of 3I Atlas pulsed subtly, once again matching the 8-hour cycle first detected earlier. Hubble's data confirmed it was not an instrumental illusion. The rhythm was real, steady, consistent, like the heartbeat of a traveler moving through the dark. Scientists began to debate. Some believed it was rotating slowly on a tilted axis. Others thought the variation came from shifting light, as the surrounding gas expanded and contracted under solar pressure. But one question lingered above all. Why did the teardrop shape remain so stable? A normal comet, buffeted by solar wind, would break apart unevenly, its outline changing constantly. 3I Atlas, however, remained intact, as if an unseen force was holding its structure together against dispersion. In one internal note, an engineer quietly wrote, "This shape is not random. It's being maintained." And at already Dell. Those words were never released publicly, but they soon became the subject of whispered discussions. Researchers began to wonder whether 3I Atlas was exhibiting a form of dynamic stability, a state in which an object continuously self-adjusts to remain in balance with its environment. If that were true, its behavior would be far more complex than anything seen in a natural comet. It wouldn't merely react to forces, it would respond to them. In the quiet hum of the control room, new images kept appearing, and each time the reflected light shifted, many swore it felt as though the object was looking back, not consciously, but through the sheer poise of its existence. Distant, silent, cold, and yet profoundly alive. One researcher whispered, "Maybe we're seeing something older than imagination itself." No one replied. Only the sound of computers and the pale glow of monitors. Outside, hundreds of millions of kilometers away, 3I Atlas drifted on, a solitary drop of light, sliding through the dark sea of space. When the Hubble images were finally processed, a larger question began to rise. Why did 3I Atlas keep its strange shape? A solitary droplet of light drifting through space, yet it did not fragment, nor tear apart under the solar wind. Scientists ran hundreds of simulations, but none could explain its near-perfect stability. It was as if the object somehow knew how to balance itself, holding equilibrium between invisible forces pulling from every direction. Gradually, they began to understand. 3I Atlas was not a wandering block of ice and dust. It carried within it a kind of delicate organization, a harmony between dust, gas, and energy. Its structure was not chaotic. It seemed to be adjusting itself in order to persist. Three-dimensional reconstructions from Hubble revealed fine eddies of dust swirling around its surface, slow, circular motions, like a faint form of respiration. Some researchers called it the object's breathing mechanism, not in the biological sense, but as a way it maintained stability within the harsh equilibrium of interstellar space. The scientific community began using a new term, intrinsic equilibrium state, a phrase both technical and strangely poetic, because if that was true, then this was no passive traveler, but a system that knew how to sustain itself. The longer they watched, the clearer that feeling became. 3I Atlas was unlike any comet humanity had ever seen. It was still within motion, calm within turbulence, preserving its form as if to remind us that existence doesn't always require power. Sometimes it only requires balance. When the last frames were assembled into a sequence, a brief film emerged. 3I Atlas drifted slowly across the screen, a soft ribbon of light gliding through darkness. Not violent, not ostentatiously mysterious, just quiet, as if it was simply passing by. And in that moment, everyone in the control room felt something profoundly human. A small, sacred awareness that perhaps they had just witnessed a pattern of the universe itself, silently continuing its work from billions of years ago to this very instant. Light is the oldest language of the universe. Before there was sound, before there was memory, every story was written in silent rays of light. And when Hubble began to analyze the spectrum of 3I Atlas, humanity, for the first time, heard a voice with no sound. Each band of light was a small message. The red, the blue, the violet. They were not just colors, but the script of matter itself, the way atoms tell the story of where they were born. In the control room, the spectral data appeared on the screen like a piece of abstract music. No images, no shapes, only peaks and gaps. But the scientists understood. Every gap was a word the light had chosen not to speak. 3I Atlas glowed in a way that was unstable, yet not chaotic. Its light pulsed, slowly, rhythmically, as though it were breathing, a gentle flicker every 8 hours, repeating like a heart, beating in the darkness between stars. No one called it alive, but everyone felt that they were listening to something meaningful. Spectroscopists found that most of the emission came from CO2 and CO, gases that react strongly to solar energy. That meant 3I Atlas was reflecting sunlight with a rhythm of its own. It did not simply absorb light, it answered. At times, its glow became so clear and steady. It seemed to shine from within, not bright, but pure, like moonlight seen through water. In several reports, scientists referred to it as reflective oscillation, a rare phenomenon where an object modulates how it scatters light, based on its position relative to the sunday. No one knew why 3I Atlas could do this, but it seemed to hold a natural mechanism within itself, something both simple and perfect. One researcher wrote, "If the universe has rhythm, then the light of 3I Atlas is one of its notes. Der wanting splake rise and with the grapta visited." That line spread everywhere, not for its science, but for its quiet beauty, because it was impossible to look at that light and feel nothing. The spectra revealed one more surprise. Among hundreds of measurements, there was no sign that the object was weakening. It did not fade. It did not crumble. It held its brightness steady for weeks, something almost impossible for any known comet, which always fluctuates wildly near the sunday. That steadiness unsettled scientists. They had seen objects brighter and larger, but none that held such unwavering light. It was as if 3I Atlas controlled its own luminosity, keeping it just enough to persist, but never enough to burn away. Some called it coincidence, a fortunate alignment of physics. Others felt it was a soft reminder that the universe might be more deliberate than we imagine. And one quiet night, as the final data downloaded, someone turned off all the lights in the lab, leaving only the spectral lines glowing on the monitor. Bands of red and green and blue shimmered slowly, as though the universe was writing a letter to humanity in light. No conclusion was made that night, but one thing became clear. 3I Atlas was not merely reflecting sunlight, it was sending a rhythm, and within that rhythm might lie the answer to why it still endures. When Hubble sent back its final images, NASA began comparing them with data from its two companions in space, James Webb and TESS, three eyes of humanity, each gazing at the cosmos in its own way. Hubble saw what the human mind could imagine. Webb saw what light hid behind dust and darkness. And TESS, it listened to the rhythm of light, that one language which never lies. When the three data streams were combined, something unexpected appeared. The light captured by Hubble and the infrared energy measured by James Webb did not just occur at the same moments, they moved in rhythm. Every 8 hours, light and heat rose together, then faded together. It was as if 3I Atlas was breathing, one breath made of light, one made of warmth. What could make a frozen body at the edge of the solar system hold such a steady pulse? Was it reacting to the sun, or simply following a law of its own that we don't yet understand? The scientists had no answer. They only knew that its light and heat did not lead or follow. They merged, perfectly in sync. A young physicist at Cambridge once asked during a briefing, "If the universe has a heartbeat, could this be part of it?" No one laughed, because no one could say the question was wrong. TESS, with its precise vision, saw something else. In data from May and June, the brightness of 3I Atlas had increased fivefold in just a few days, then stopped, as if someone had switched it off. No dust, no gas, no trace of outburst, only light, changing, suddenly and silently. Have you ever thought that an object, hundreds of millions of kilometers away, might choose how it shines? Not to be seen, but simply to keep existing within the light itself. When the three data sets were aligned, the pattern became clearer. 3I Atlas was not merely reflecting sunlight. It seemed to remember it. Each ray that touched it, part of it was sent back, part of it was kept within, and later released slowly, like a breath, as though the object lived inside its own memory. A researcher wrote in their report, "It doesn't reflect light, it keeps it." What if that were true? What if, out there, some things could store light, the way memories live in the human mind? Not intelligence, but an ancient reflex, matter responding to energy and remembering the touch. Hubble spoke in visible light, Webb in warmth, TESS in rhythm, three voices merging, and the world, for the first time, heard a melody from afar. One of the observers whispered, "It feels like we're listening to an ancient song. We just don't understand the words." Perhaps that's true. The universe does not speak in sentences. It speaks in light, in silence, and in the slow repetition of its own cycles. And sometimes, if we listen long enough, we begin to understand. That silence is a language too. October 2025. 3I Atlas was drifting closer to the sun, crossing that invisible line where light grows too strong, and every instrument begins to fail. Most ground-based telescopes had already gone dark. Even Hubble was forced to shift its orbit to escape the glare radiating from the solar disk. The last frames came back blurred, washed out by streaks of radiation. Nothing clear remained, only a trembling glimmer at the edge of the image, a final farewell written in light. That was the moment humanity began to understand. That silence, too, is a kind of data. When everything becomes too bright, when a signal is drowned by the very energy that creates it, what remains is the absence. And absence, it turns out, can speak. At the control stations, the monitors turned gray. No errors, no alarms, just nothing left to see. A perfect void, a silence born from light itself. Researchers called this stage the perihelion blackout, the point of closest approach, when the object vanishes inside the blinding corona of the Sunday. They knew 3I Atlas was still there, moving through a region where heat could reach 200 degrees Celsius, and solar radiation was strong enough to tear apart the smallest grains of dust, but no one knew what would happen next. It might fragment into thousands of pieces, evaporate completely, or, if luck held, pass through untouched, emerging again on the other side, as if nothing had ever happened. During those days, the observatories could only wait. No new signals, no updates, only time, stretching quietly beneath a flood of light. Scientists described it as standing at the edge of existence. They had followed 3I Atlas for months, analyzing every photon, and now it was gone, out of reach, like speaking to a friend, and suddenly losing the radio signal. And in that silence, something subtle changed. They began to realize they were no longer studying an object, but a journey, a flow of knowledge and emotion, both scientific and profoundly human. 3I Atlas had vanished from view, but not from their thoughts. Models kept updating, new hypotheses formed, as if the human mind itself was trying to fill the void that the universe had left. On October 30th, the object reached perihelion, its closest point to the Sun, 1.4 astronomical units. At that distance, no telescope could see it. Yet several stations reported faint disturbances, a weak, rhythmic oscillation in the radio spectrum, a pulse repeating, as if some distant signal were fighting to pierce the sea of light. No one dared to claim it was 3I Atlas, but no one could dismiss the coincidence either. When the final readings came in, the world fell silent. No light, no image, only a quiet thought of something passing calmly through the brightest place in the solar system, unafraid, unmarked, and still moving forward. Perhaps that was its beauty, an existence that needed no proof, a presence that sought no attention, only the freedom to continue its path. And as humanity sat before its darkened screens, no one could yet know that beyond the glare, 3I Atlas was preparing to return. Early November 2025. 3 days after 3I Atlas passed perihelion, the James Webb Space Telescope began to pick up faint signals. A pale streak appeared at the edge of its infrared images, like a ghost emerging from behind the Sunday. No one knew whether it had survived. For weeks, every observatory had heard nothing, only background noise and lines of empty data. And yet, now, the light had returned, faint, but rhythmic, like the slow breathing of something that had just walked through fire. James Webb sees in a world invisible to human eyes, where heat is color and every vibration carries the voice of atoms. The incoming data was dense, layered, spectral lines stretching like the strings of a silent instrument. And in the first session of analysis, everyone saw it. Something was different. 3I Atlas was not releasing water vapor. No, H2O, No trace of the familiar signature of comets, the unmistakable breath of ice turning to steam under solar heat. Instead, its spectrum was dominated almost entirely by two molecules, CO and CO2, carbon monoxide and carbon dioxide. Their levels were so extreme that some scientists rechecked their instruments, suspecting a calibration error. But the numbers held. Meanwhile, water, methane, and every other organic compound had vanished from the readings. That wasn't supposed to happen. If 3I Atlas had formed from frozen ice, water should have been its main component, but it was silent. While CO and CO2, molecules that normally exist only in ultra-cold, low-pressure environments, filled the entire spectrum, the emission lines didn't stay still. They drifted slightly over time, as if the source of the gases was shifting direction every few minutes. This led to a daring hypothesis. Perhaps the object wasn't simply releasing gas, it was guiding it. In a report to the Goddard Space Flight Center, one researcher described it as the intelligence of matter, not in a biological sense, but in a physical one. Matter capable of reorganizing itself to maintain equilibrium. When James Webb scanned the region again, it detected something even stranger. Fine streams of dust weren't moving away from the sun. Some were moving toward it. That shouldn't be possible. No known physical law allows dust to travel against the push of solar radiation. And yet, there it was, microscopic particles, less than a micron wide, moving upstream, as if propelled by the very CO2 jets. The object itself was venting. The phenomenon was soon given a name: the backthrust effect, a mechanism by which an interstellar body appears to generate an internal counterforce, stabilizing itself within the chaos of solar radiation. This was no ordinary comet. It was a structure that responded. In the following days, James Webb kept watching. The light of 3I Atlas grew stronger, not from sunlight, but seemingly from within. Its spectrum shifted slightly toward the red, a sign of internal heat being released. No one could explain how. Some plasma physicists proposed that high-pressure carbon molecules were reacting in ways never before observed, but their models failed to reproduce the pattern. Every team reached the same uneasy conclusion. This was a phenomenon beyond precedent. In the final note of a report sent to ESA, someone added a single line: "The object emits energy not derived from the sun, not by thermal cycling, and by no known mechanism." Once again, 3I Atlas stood silent before every human definition. The last image from that first week of November showed the object intact. No cracks, no fragmentation, no sign of decay. Only a soft halo of gas surrounding it, dim yet persistent, like a candle burning against the solar wind. For those who had followed it from the beginning, this was more than the return of a distant traveler. It was the return of a question, a reminder that the universe still knows how to make humanity look up. As the James Webb data was examined in greater detail, one truth emerged with quiet certainty. Water said nothing. The spectral lines that should have marked water vapor, those familiar sharp signatures found in every comet ever studied, were utterly blank. No signal, no noise, just a perfect silence across the wavelengths where life usually speaks. The scientists stared at the graphs, and for a long time, no one moved. There was no known theory to explain it. Water defines a comet. It governs its heat, its brightness, its evaporation, its very behavior. Without water, a comet is not supposed to exist. But 3I Atlas seemed to be written in another language, Instead of H2O, its entire spectrum was drawn in the script of carbon, CO and CO2, two molecules that stand opposite to the chemistry of life, yet remain the final whispers of combustion and decay. It was as if 3I Atlas had not been born from a place of creation, but from the ashes of extinguished stars, a product of death, not of beginning. That idea reshaped how scientists saw it. Perhaps 3I Atlas did not come from a young, radiant system, but from a region long cooled, a realm where matter had been reforged in the dark. Even the carbon signatures behaved strangely. Normally, carbon dioxide gas escapes freely toward the path of least pressure. But in 3I Atlas, the emissions seemed to flow toward the brightest direction, toward the Sunday. A reversal of thermodynamics itself. Researchers described it as a form of positive energy orientation, a behavior where matter appeared to seek light, not flee from it. Spectroscopic readings confirmed it. The internal CO2 pressure increased whenever the object faced the sun, then dropped instantly when it turned away. No thermal delay, no cooling time, just instant response, as if the entire structure were synchronized by a hidden network. It was now undeniable. 3I Atlas did not behave like a comet. It acted with order, as though governed by an internal system of control. The first simulation models suggested that the outer carbon layer could be bound by weak electrostatic fields, forming a thin crystalline mesh around the object. When sunlight struck, the energy didn't just evaporate material, it activated the mesh, causing a chain reaction of reflective oscillations, a kind of resonant shimmer across the carbon lattice. No one dared to call it artificial, but all agreed that the universe had just revealed a form of organized matter that science had no name for. In private reports, researchers began using a new phrase, intelligent chemistry, not intelligence in the biological sense, but a placeholder for systems of matter that can react flexibly, self-stabilize, and regulate energy within hostile conditions. 3I Atlas seemed to embody that idea perfectly. It needed no water, no ice, no complex biological machinery to endure. With only carbon and oxygen, it composed a quiet symphony of reflection, balance, and persistence. Some compared it to an ancient reflex of the cosmos, a way matter might have behaved before life ever emerged. Not yet alive, but already aware enough to endure. Perhaps that's why, when scientists looked at its spectrum, they felt as if they were reading a forgotten memory, a record written in the language of atoms, carried across billions of years by starlight. James Webb kept listening. The spectral bands grew denser, a chemical epic unfolding line by line. But with each new data set came deeper mystery. No decay, no exhaustion, only a steady, unbroken existence. As if 3I Atlas were untouched by time. It moved, glowed, dimmed, then brightened again, following a rhythm no one could predict. Science could record every number, but not define the meaning, because sometimes there are things in the universe not made to be understood, only to be witnessed once and forever. In the first days of November, as James Webb continued to follow 3I Atlas, a strange new pattern began to emerge from the infrared data. The fine dust surrounding the object wasn't drifting outward as every comet ever observed should. Instead, it was slowly moving toward the Sunday, a motion so counterintuitive, so impossible, that the team at first thought it had to be an error. Solar radiation, billions of photons slamming into every dust grain. should push everything away. That pressure is what forms a comet's tail, a law of celestial mechanics written centuries ago. But 3I Atlas defied it. The tiniest particles, only a few micrometers across, were gliding inward, as if drawn toward the light. The initial suspicion was interference, but after comparing consecutive image sets, the direction held steady, repeating, consistent, rhythmic, not noise behavior. Those particles weren't being scattered. They were circling in subtle vortices, then converging toward the object's sunlit face, toward the very place radiation should have been pushing them from. The NASA analysis team went quiet. No simulation could reproduce the effect. No known force could make dust travel upwind. A new hypothesis emerged. Perhaps 3I Atlas was generating a form of secondary pressure born from the carbon dioxide jets erupting on its dark side. If those jets converged toward the illuminated hemisphere, they could create a temporary low-pressure pocket, a kind of artificial pull, drawing particles back toward the Sunday. It was plausible, but it didn't explain the stability. Every oscillation stayed within a narrow band, as though an invisible regulator was keeping the entire system in balance. In the infrared frames, the object glowed steadily, its dust bands curving into soft arcs, ripples of light swaying in silence. The image resembled a solar sail, but one not made by engineers, a natural sail, steered not by fuel, but by the resonance of gas and sunlight. If true, then 3I Atlas was using the sun itself to navigate, a propulsion mechanism humanity had only theorized, now unfolding effortlessly in the void. An internal ESA report described it this way: the object demonstrates photonic guidance behavior, a form of response not spontaneous, but energetically deliberate. Let's not one-place the daver. The phrase energetically deliberate spread quickly through the research community, not because anyone believed it was technology, but because it forced a different kind of realization, that matter itself could act as if it understood its surroundings. Particle physicists began studying the carbon structure of the outer shell. They found traces of weakly ionized CO2, tiny negative charges scattered across the surface. When struck by solar photons, these charges created faint local electric fields, just strong enough to nudge dust in unexpected directions. That meant 3I Atlas was using light to steer itself. No engines, no mechanical system, only the quiet precision of photonic and electric balance. Nothing like it had ever been seen. It was a natural machine, a self-stabilizing, radiant structure that refused to fall apart, even while flying through the most hostile region of the solar system. In the control room, the replayed infrared sequence filled the monitors. 3I Atlas pulsed like a heartbeat, its dust bands bending gently against the sunlight. The room stayed silent, not from fear, but from awe. As the object drifted slowly beyond the final frame, the infrared light continued to pulse, steady, alive, enduring, like the heartbeat of something learning to adapt. And in that moment, a quiet realization passed through the room. Perhaps the universe doesn't need living beings to express intelligence. Given enough time, matter itself learns how to exist wisely. After the phenomenon of self-sustained emission was confirmed, the research teams turned their focus inward toward the heart of 3I Atlas. No one doubted anymore that something extraordinary lay within it, a form of matter unknown to science, a silent core beating inside an interstellar glacier. Through precise optical oscillation measurements, James Webb detected that the central region of the object wasn't a static, frozen mass. It responded to light, brightening when struck by solar radiation, dimming when the infrared wavelengths weakened. But the change wasn't random. It had rhythm, a slow, deliberate rhythm, the response of matter that seemed, somehow, to be listening. No thermal model could account for such behavior. Any structure made of ordinary ice or carbon should have vaporized long ago. Yet the core of 3I Atlas held firm, as though bound by an invisible lattice of energy. Physicists began to whisper a daring hypothesis. The core might be composed of an exotic form of matter, known as low-energy resonant material, a structure in which energy doesn't travel outward, but loops endlessly back into itself, oscillating in a closed circuit. According to this idea, each particle inside the core acts as a tiny energy reservoir. When excited by radiation, it doesn't absorb and decay. It re-emits the same energy in mirrored waves. Wave meets wave. They amplify, sustain, and preserve one another, creating a stable pocket of harmony in the middle of chaos. In other words, this matter doesn't just react to energy, it remembers it. A scientist at ESA offered a simple metaphor. If you pluck an ordinary string, it rings once. But if you pluck a string made of 3I Atlas, it would ring forever, each echo awakening the next. The greed often, then main it is a ben merk in the work. That image led many to draw parallels with quantum memory, where energy doesn't vanish, but remains suspended in superposition. Of course, 3I Atlas wasn't a quantum device, yet the resemblance was unsettling. It seemed to be retaining light instead of letting it go. During internal meetings, researchers began calling this region by a new name, the memory core, not as a metaphor for consciousness, but as shorthand for matter capable of recording, responding, and persisting through change. Further analysis showed that the energy density inside the core was 8 times higher than that of its outer shell. Yet it emitted no heat. The energy was trapped in a latent state, like a still lake, hiding thousands of ripples beneath the surface. Some theorists proposed that the core had formed in a quiet corner of space where magnetic fields are weak, a place where ancient particles remained isolated for billions of years, slowly evolving into a stable, resonant structure. Such matter able to conserve energy without consuming it had been predicted in mathematical models, but never observed in nature. Until now, if that theory proved true, then 3I Atlas wasn't merely an interstellar object. It was a cosmic archive, a drifting energy vault, carrying the imprints of supernovae and the memory of when matter first learned how to arrange itself. During one online briefing, a physicist from Caltech quietly remarked, "Maybe this is how the universe remembers itself." The phrase spread quickly. For days afterward, scientists everywhere referred to the memory of matter, not as mysticism, not as life, but as the simple recognition that every atom in the universe may hold a record of the energy that once passed through it. 3I Atlas became the living proof of that idea, a silent body, without sound or pulse. Yet every time light touched it, it answered, not to communicate, but to remind the cosmos that it still existed, still holding its ancient trace of radiance. In the final infrared frames of this observation phase, the object appeared like a dim crystal, glowing softly from within. Light swelled outward, then receded like breath, a gentle rhythm, but profound, as if the universe itself were replaying its own memory. When the day's last data file was archived, a researcher typed a brief note into the report. The object maintains energetic resonance without instability. It behaves as if it remembers. There is not town one, it is cried to Adadol and Minesis, a single sentence, carrying the weight of humanity's awe before a fragment of matter that seems to remember the light. When the final streams of data came in, every gaze converged on a single question. What is 3I Atlas? No one could answer. Yet within the silence of numbers, an idea began to take shape, that perhaps the universe was looking back at itself through this object. For so long, humanity believed it was the observer. They built telescopes, measured photons, and wrote equations to decode the cosmos. But 3I Atlas forced them to pause, to wonder whether, all along, it was the cosmos using their eyes, to gaze upon its own reflection. Each spectral line, each carbon shimmer, was like a mirror, reflecting not only light, but the very laws of existence. Physicists soon noticed something uncanny. Every model, built to simulate 3I Atlas, produced results eerily similar to early universe energy balance equations. The oscillations of the core, the resonance ratios, the delays in light response, they all mirrored data from models of cosmic background resonance, the faint hum left over from the Big Bang, as though the object carried G's, the same resonant fingerprint as creation itself. The room fell quiet. No one claimed certainty, but no one could deny it either. 3I Atlas might be older than planets, a relic not from our solar system, but from the beginning. Some began to call it the cosmic mirror, a point where all light and memory gather and rest in stillness. Not the center of the universe, but its reflection within its luminous cycles. Spectroscopists found another pattern. Ratios of 1, 2, 3, 5, 8. The Fibonacci sequence, woven into galaxies, seashell spirals, and the rhythms of living things. Coincidence, perhaps, or maybe the same universal tendency, the resonance of order choosing, the simplest path to endure. One physicist said quietly, "Resonance was the first language of the universe. If 3I Atlas is resonating, it's speaking that ancient tongue. In the Didits, 1, the words spread like a quiet revelation. They stopped trying to define it and simply began to listen, the way one listens to music, without needing to understand the lyrics. And as the cycles continued, another subtle shift appeared. The reflected light turned faintly blue. Not a flare, not decay. A cooling, gentle transformation, as if the object were settling into the memory of itself. Some said it looked like light returning home, a soft glow, calm and forgiving, like the universe recalling something it had once forgotten. A philosopher in Vienna wrote, "If the universe is conscious, then 3I Atlas is the instant it remembers itself." No one argued, because in every image, in every pulse, 3I Atlas seemed to do what no object had ever done, not merely exist, but reflect back the architecture of existence itself. Younger researchers began calling it the principle of cosmic reflection, not a law of physics, but a way of seeing that everything which exists is simply the universe observing itself through another form. When James Webb's final dataset closed, the last pulse of 3I Atlas remained steady, not rising, not fading, but holding like a silent farewell. And in that glow, humanity understood something profound. They too were reflections, not just in glass and data, but in awareness itself. 3I Atlas had shown them humility. that to understand the universe, one sometimes needs only to stand still and let it look back through you. In the early months of 2025, the TESS satellite, a quiet wanderer in high Earth orbit, was performing its routine duty, scanning the stars for distant worlds. By measuring their faint rhythmic flickers of light, no one noticed that, amid that vast ocean of data, something uninvited had entered the frame. A single bright speck, unlisted, unclaimed, unaligned with any known star system. It appeared only for a moment, then vanished, as a president of fission, like a mote of dust catching light in the void. But TESS never forgets. Its automated systems recorded every pulse, every fluctuation, and 6 weeks later, when the Feinstein-Seligman team reviewed the archives, they found something that defied explanation. Among millions of still points, one had moved. Its brightness surged fivefold in just a few days, then abruptly stopped, as if someone had flipped a cosmic switch. There was no interference, no gamma burst, no trace of radiation or collision, just a single immaculate flash, isolated, deliberate, and unlike any cometary behavior on record. When the team compared the timestamp with later data from Hubble, a chilling realization emerged. The light surge had occurred 2 months before 3I Atlas was officially discovered, which meant that the object had entered a phase of high-energy activity, while still 6 astronomical units from the Sun, a frozen realm where comets sleep, motionless and inert. TESS could not see its shape, but it could feel its rhythm. The pulse of light didn't scatter randomly, like a natural reflection. It was focused, precise, like a heartbeat made of photons. No one understood how it was possible. There was no eruption, no vapor, only energy. As scientists reconstructed the light curve, a subtle pattern appeared. The brightness rose sharply, then faded slowly, a controlled release, as though the object was choosing how to shine. In internal meetings, a new phrase began to circulate: intentional brightening, a term that didn't exist in astrophysics, but fit 3I Atlas perfectly. From that moment, everything changed. TESS, once a mere planet-hunting sentinel, had become witness to a phenomenon beyond precedent, an interstellar visitor that seemed to modulate its own light before humanity even knew it was there. A scientist on the team wrote a single, quiet line in the summary report: the luminosity increase of 3I Atlas occurs without thermal cause. If not reflection, then emission. That sentence, small, almost hesitant, ignited a storm of speculation, theories of cold plasma reactions, internal energy storage, and non-thermal emission mechanisms began to bloom like sparks across the scientific world. And when the final test datasets were released, one truth became undeniable. TESS had seen it first, before Hubble, before James Webb, before anyone even knew that 3I Atlas existed. Yet perhaps the strangest part was not the data itself, but the timing. TESS hadn't been programmed to find it. It had simply looked at the right place, at the right moment, as though the universe had chosen that instant to speak in its oldest language, light. After the first surge of light, TESS kept its silent watch on the same coordinates for weeks. Everything seemed to return to calm. The light was steady, the data clean, no further anomalies. Then, in mid-June, a new pattern appeared. It wasn't another burst of brightness, but a flicker, irregular yet rhythmic. One strong pulse, 2 faint ones, then silence, then again a flash, brief and deliberate. When the data was processed, the pattern emerged with startling precision. Each interval lasted exactly 33 minutes. Not 32, not 34, always 33. At first, the team suspected an instrumental glitch, perhaps a reflection from Earth, or a timing error in the satellite's rotation. But cross-checks from other orbital sectors were flawless. The phenomenon occurred only in that narrow field, the region where 3I Atlas was moving. TESS wasn't built to listen for radio signals. It could only see light, but it could see it down to a millionth of a degree of brightness. And in that exquisite sensitivity, it caught what no other instrument did: light speaking in rhythm. When analysts plotted the data, the waveform wasn't continuous. It was a series of discrete peaks, separated by gaps of silence, like coded intervals, a visual Morse. No one dared call it a message, yet the feeling was undeniable. The light of 3I Atlas behaved less like reflection and more like modulation. A team at NASA Goddard tried something different. They translated the pulses into sound, frequency for frequency. When the playback began, the control room filled with a low, resonant hum, a slow, deliberate beat, soft as a heartbeat echoing through metal. Someone whispered, "It sounds like it's responding." No one answered. Some truths are too vast to speak aloud. Further analysis revealed the pulse wasn't alone. Secondary harmonics appeared, cycles at 66 and 99 minutes, perfect multiples of 33, a flawless harmonic pulse sequence. In astrophysics, such harmonics belong to neutron stars, or the plasma waves spiraling near black holes, but never, to a free-floating interstellar object, especially one adrift 6 astronomical units from the Sunday. No nearby gravity well, no magnetic field, no known mechanism could account for such precision. Then came the comparison with James Webb data. The same 33-minute rhythm pulsed, not only in visible light, but in the infrared emission. 2 energies, 2 wavelengths, 1 heartbeat. That was the moment speculation ended. This wasn't an external effect. It was intrinsic behavior. 3I Atlas was regulating its own energy, keeping rhythm within itself. As planets spin, as hearts beat. No one knew why it chose 33 minutes. Some called it coincidence, others, a natural resonance between energy states. But for those who watched the live sequence, it didn't feel random. It felt deliberate, a pattern born of some deep order. Beneath matter and light, TESS continued observing for 4 more days. The signal slowly weakened, but never vanished. On the final reading, still 33 minutes, a faint glimmer pulsing softly, like a farewell. In the mission log, the final entry contained only 4 words: "The object still beats." When the report on the 33-minute pulse was released, the scientific world awoke as if from a long sleep. From Harvard to Kyoto, Paris to Cape Town, research centers everywhere turned their telescopes toward the same patch of sky. 3I Atlas, the third known interstellar visitor, had suddenly become the axis around which every discussion, every model, every doubt revolved. Dozens of teams began running simulations, comparing spectra, and trying to reproduce that rhythm in their equations. But none succeeded. No reflective surface, no resonant mechanism could hold such perfect timing. 33 minutes, unwavering, for days on end. Some astronomers proposed a resonance between layers inside the core. Others blamed plasma interference from solar activity. But every hypothesis fell back onto the same question: why only this one? If interference, why not in nearby objects? If reflection, why so precise, so constant? The question escaped the walls of academia. Across continents, amateur observatories aligned their lenses: Canada, South Africa, Vietnam, Chile. And one night in June, several small stations reported faint flickers, oscillations at exactly the same frequency. It was as if the whole planet heard a distant heartbeat echoing through the dark. Some laughed, saying the universe must be sending its pulse to Earth. But behind the laughter was a quiet sense of awe, the feeling that something was communicating. Have you ever looked up at the sky and felt that it was looking back, not with eyes, but with the long, patient silence of space? That was the feeling now shared by thousands. From dry lines of data, humanity once again felt it was in conversation with the cosmos, not through words, not through sound, but through light, the only language that travels without need of air or matter. At NASA, a special task group was formed, the TESS Interstellar Review. Their job was singular: to listen to light. Every oscillation was turned into sound, every fluctuation into rhythm. When played aloud, it filled the room with a low breathing cadence. Someone said, "If light can feel, then this must be the breath of the universe." Meanwhile, ESA, JAXA, and the Harvard Center for Astrophysics launched parallel studies. For the first time since the Voyager probes left the solar system, humanity had a single shared point to look toward. The wave of research was immediate. By July 2025, in just 3 weeks, over 70 scientific papers appeared, from plasma resonance theories to hypotheses about ancient self-stabilizing matter to bolder ones, that the 33-minute pulse might be a form of programmed emission. No one dared speak the word artificial, but everyone felt its shadow in the room. Could 3I Atlas be merely a wandering fragment of interstellar debris, or something sent long ago by a civilization so distant, so old, that its light is only reaching us now? At a Caltech symposium, one scientist said quietly, "Whatever 3I Atlas is, it's making us feel small, in the most beautiful way." That line spread everywhere, because indeed, science had rarely moved people to tears before. These bands of light were no longer numbers, but the rhythm of something beyond definition. And so you might wonder, if somewhere out there, an object pulses every 33 minutes, and we just happen to notice, is it simply physics? Or a brief encounter between two forms of existence, one made of light and one made of curiosity? As the world's observatories still argued over the nature of the 33-minute pulse, a new rhythm began to surface quietly, almost shyly, not from TESS this time, but from other satellites. Machines never meant to study interstellar mysteries. High above Mars, NASA's MAVEN orbiter registered faint oscillations in the plasma field of the Martian atmosphere. The frequency of those waves, when cross-checked, matched almost perfectly the light rhythm of 3I Atlas, 33 minutes. No one believed it at first. MAVEN was built to study the solar wind, not signals from something hundreds of millions of kilometers away. But deeper analysis showed the waves weren't coming from the sun's direction. They came from the region of space where 3I Atlas had last been seen. Almost simultaneously, SOHO, the sun's veteran sentinel, detected faint ripples in the solar plasma. They rose and fell on the same 33-minute cycle, appearing, fading, then returning again. Two independent spacecraft, two matching rhythms. Suddenly, the picture sharpened. The emissions of 3I Atlas were not purely optical. They extended outward as weak electromagnetic waves, a resonant signal capable of rippling through the plasma sea of space. When signal processing teams synchronized their data, the peaks aligned to the second. From Mars's orbit to Earth's, from 1.4 AU to 0.98 AU, the rhythm held true. It was no longer a local phenomenon. It was interplanetary resonance. In physics, resonance happens when two separate systems begin vibrating in unison. But here, the resonance needed no clear medium. It traveled through emptiness, through solar wind, through planetary magnetic fields. The first models called it cross-resonance, a process in which energy from one source triggers sympathetic oscillations in other electromagnetic domains, as if all of space were a vast instrument. And 3I Atlas had just struck its first note. ESA's measurements confirmed the propagation delay, a 23-second lag between Mars and Earth, exactly the time light would take to cross that distance, proof that the signal was real, not error, not echo. By early August, the amplitude began to fade, but the rhythm did not. The beat weakened, yet never vanished, like the lingering hum of a bell, reverberating through vacuum. Plasma physicists compared the phenomenon to Alfvén waves, magnetic oscillations in the solar wind, but those depend on magnetic direction. This wave did not. It radiated equally in all directions, untethered to any field line, disobedient to known plasma laws. A group in Kyoto proposed a daring model, self-induced resonance, a system that excites waves from its own energy, then amplifies them through feedback, maintaining a fixed period. If true, 3I Atlas was communicating with space itself, in its own native frequency. No one dared call it a signal, as I had madly Rustem, yet everyone felt the same unease, that something was spreading, not just as light, but as rhythm. Late-month reports added another layer of mystery. During the resonance phase, Earth's magnetic field sensors recorded tiny oscillations in the ionosphere, fluctuations only a few parts per billion of a Tesla, but synchronized perfectly with the 33-minute cycle. There was no denying it. The phenomenon had reached Earth. From a single point of light drifting through space, 3I Atlas had turned the entire solar system into a vast resonant chamber, a shared heartbeat, silent yet measurable. And in that moment, science ceased to be a line dividing humankind from the cosmos. It became part of the composition itself, a symphony in which 3I Atlas played the opening note, and Earth, unwittingly, had begun to sing along. The 27th of August 2025. As 3I Atlas reached its most favorable position for Earth-based observation, the Gemini South Telescope in Chile opened its vast eye to the cosmos. Atop Cerro Pachón, a mountain crowned by dry, thin air, the first photons from the third interstellar visitor fell onto Gemini's 8.1-meter mirror, a silent rain of light from beyond the stars. The image emerged, no longer a solitary speck adrift in darkness. This time, 3I Atlas revealed itself as a slender streak of light, a fine dust tail stretched across a motionless sky. Not brilliant, but distinct, like a line of chalk drawn across the infinite blackboard of space. Its tail did not fan out evenly. The head was dense, sharp, and bright. The trail curved gently, as if tugged by an invisible cosmic breeze. Yet the form itself was not the shock. The length was 3 times longer than what Hubble had seen in July, long enough, if placed near Earth, to span the entire orbit of the Moon. Spectral analysis revealed unmistakable traces of cyanide. The CN compound, a chemical signature typical of an active comet. Ordinarily, when water sublimates from a comet's core, it releases hydrogen cyanide, which, under sunlight, breaks apart and glows a soft blue. But this time, cyanide appeared without water vapor, a chemical impossibility. The data were checked, recalibrated, checked again, yet the result held. An emission rate of 8 times 10 to the power of 23 molecules per second, a figure belonging to hyperactive comets on the verge of disintegration. And still, 3I Atlas showed no sign of losing mass. It behaved like a sealed reactor, releasing energy, while keeping its substance intact. Gemini's readings showed clear layering within the dust tail, an outer sheath, bright and diffuse, an inner filament, darker, denser, and astonishingly stable over hours of observation. Thin ridges of light traced along the tail suggested the object was rotating slowly, once every 7 to 8 hours, almost the same cycle as the energy oscillations James Webb had recorded earlier. Light, gas, and motion, all beating to the same rhythm. There was no longer any doubt. 3I Atlas was a closed energy system. It did not merely shine. It breathed, through dust, through gas, through motion itself. In multispectral images, Gemini captured hues of blue-green, filaments of cyanide light shimmering across carbon dust, like morning mist on a desert of photons. It no longer felt cold or distant, but faintly alive, a warm lantern adrift in the void. When the first images were released, the world paused once more, not because it was the brightest object in the sky, but because it looked strangely familiar, as if humanity had dreamed of it once, long ago. A quiet, enduring traveler, continuing to write its story upon the canvas of the heavens. The next images from Gemini South revealed something unexpected. When researchers increased exposure and filtered out optical noise, the tail of 3I Atlas no longer appeared as a single stream of light. 2 distinct structures separated from the nucleus, a pale gray dust tail and a blue ion tail, each pointing toward a different quadrant of space. This split was not random. It was the result of 2 kinds of matter obeying 2 different forces, sunlight pushing dust one way, while charged particles were pulled along by the solar plasma wind in another. Yet the baffling part was that both tails pulsed together every 33 minutes, the same period first seen by TESS. The outer dust layers shifted color slightly, then faded back, as though the entire structure were synchronizing to a central rhythm of energy. Spectral readings confirmed the presence of partially ionized carbon grains, signatures of complex photochemical reactions. Instead of scattering or drifting away, these particles moved in subtle spirals, organized currents adjusting to the surrounding magnetic field. Not chaos, but choreography. In consecutive frames spaced hours apart, the dust tail appeared to breathe. Layers drifted outward, then folded back in, a motion almost organic, defying every model of solar wind dynamics. Scientists from the European Southern Observatory noted something stranger still. The dust did not slow with distance, as all comets do. Its particles maintained a constant velocity, over tens of thousands of kilometers. The hallmark of a weak yet stable electric field, as if the comet were wrapped in its own electromagnetic cocoon. A new hypothesis emerged. 3I Atlas might carry a net electric charge, surrounded by a thin plasma shell. That shell, interacting with the solar wind, could emit cyanide light in rhythmic pulses and push dust into its twin tails. When this model was simulated, the results left the team silent. Across 10 full cycles, the dual tail structure remained steady, refusing to disperse even under continuous radiation. It was, by all accounts, self-sustaining. In plasma physics, such behavior has a name: electrodynamic self-maintenance, a phenomenon so rare, it has only been achieved under controlled conditions in terrestrial labs and never observed in nature. The Gemini data was sent to research centers worldwide. Though analyses varied, they converged on the same realization. 3. I Atlas was not a fragment of ice decaying in sunlight. It was a working energy system, a structure that regulated itself. From those twin luminous trails, humanity began to glimpse something extraordinary, a process both physical and almost biological, matter learning to adapt, to preserve its form. Amid the hostility of interstellar space, as the Chilean sky darkened, Gemini closed its lens. The final reflections shimmered faintly, a delicate streak of cyanide blue lingering on the mirror, a small trace, but enough to remind us that the universe still tells its stories, just in a language we are only beginning to learn. When the Gemini South spectrographic data began streaming in, research teams across Europe and the United States started peeling back the layers of light, decoding each wavelength, as though they were reading a message left behind by 3i Atlas itself. Every spectral line, a word; every gap, a silence. And within that light, they found something strange, not in what was present, but in what was missing. Alongside the strong signature of CN cyanide, the entire family of long-chain carbon compounds, C2, C3, and CH, was almost completely absent. Not faint, not drowned out by noise, but truly non-existent, a chemical void, a silence between frequencies. Immediately, astronomers thought of another interstellar wanderer, 2I Borisov, discovered in 2019, which had also shown signs of long-chain carbon depletion. But in 3I Atlas, the absence was absolute. If Borisov had been an exception, Atlas was a violation, a body that broke every rule of known chemistry in comets. In nearly every comet born within the solar system, carbon appears in long molecular chains, byproducts of the complex chemical alchemy that takes place in the protoplanetary disk. They are the chemical DNA of early life, traces that normally blaze bright in reflected spectra. Yet here nothing. Such emptiness could only mean one thing: the object must have been formed in a region so cold, so far from any starlight, that chemical reactions froze before carbon chains could ever form. A world of ice, beyond the reach of suns. The Max Planck Institute proposed a startling idea. 3I Atlas may have originated in a pre-stellar zone, a field of frozen nebulae that never collapsed into a star. If true, then this object did not merely come from outside our solar system. It came from an earlier epoch of the universe, from a time when stars themselves had yet to be born. In their report to Astronomy and Astrophysics, one italicized line stood out. This object may contain material from the primordial universe, a relic unaltered by stellar heat or fusion. The phrase primordial universe spread quickly. No one could see 3I Atlas as a mere comet anymore. It was a time capsule, a fragment of cosmic history sent forth long before humanity existed. Further measurements confirmed the imbalance. CO and CO2 dominated its spectrum at unprecedented levels, while water vapor and methane were nearly absent, a chemistry too stable, too deliberate, as though some hidden process had stripped away every reactive molecule and left behind only what could endure. A bold hypothesis emerged that the core of 3I Atlas might not be an icy mix at all, but a solid crystalline form of CO2, compressed under ancient high pressure, a material so inert it could drift for billions of years without melting. If so, then every photon we detect from 3I Atlas today is a reflection of light, touching matter that predates the birth of the sun itself. To look at it is to look into a time before light. Gemini South continued observing for 3 nights. The stacked spectra formed a layered portrait of a frozen world. No methane, no ammonia, only carbon monoxide, carbon dioxide, and faint traces of nitrogen, a composition so cold it bordered on perfection. At the end of one report, a researcher added a quiet line, half scientific note, half confession: "We are seeing matter that has never known the heat of a star." That sentence was quoted everywhere, not for its poetry, but because it captured the most humbling revelation of all, that amid the chaos of radiation, gravity, and time, the universe had preserved something utterly untouched. 3I Atlas, in that moment, was no longer just the third interstellar visitor. It became a reminder: not everything in the cosmos is made to change. Some things exist simply to remember. After the compositional results were released, the scientific world turned its full attention to comparison. The question dominating every conference was clear: how did 3I Atlas differ from its predecessor, 2I Borisov, the second interstellar visitor that crossed the solar system back in 2019? At first glance, the two seemed alike. Both traveled at extraordinary speed. Both showed signs of energetic outgassing, even while still far from the sunday. And both shared the same mysterious depletion of long-chain carbon compounds. But the deeper scientists looked, the more those similarities began to dissolve. Borisov's path had been simple: a quiet hyperbolic curve from the direction of Cassiopeia, slipping through the solar system, and vanishing again into the dark, with barely a whisper of gravitational interference. 3I Atlas, on the other hand, was different from the start. Early optical data from Hubble revealed an anomalous orbital drift. After each brightening event, its actual position on the star maps was offset by several arcseconds from predicted models. At first, the discrepancy was blamed on calibration errors, but when cross-checked with TESS, James Webb, and Gemini, the deviation remained, and it was growing. The phenomenon soon had a name: non-gravitational acceleration. This occurs when a body ejects material in one direction, creating thrust that alters its trajectory. Comets can do this too, but 3I Atlas's acceleration exceeded all known cases. By August, its average acceleration was 7 times stronger than Borisov's, yet astonishingly steady, as if driven by a cyclic engine rather than random gas vents. At the University of Tokyo, a dynamic simulation revealed something extraordinary. The direction of 3I Atlas's deviation always aligned with the solar wind itself. It wasn't being pushed by the wind. It was sailing with it. If Borisov was a passenger, Atlas was the pilot of its own ship. New theories surfaced. Some suggested that its surface possessed electrodynamic structures capable of subtly tuning its interaction with surrounding plasma, creating gentle but controlled propulsion. Others, more daring, proposed that 3I Atlas might be influenced by a non-local magnetic field, a remnant of interstellar magnetism stable over billions of years. If that were true, then 3I Atlas was not drifting freely through space, but moving along an invisible lattice, a single particle in a vast cosmic web. Joint ESA-NASA studies soon confirmed another anomaly. While Borisov slowed after perihelion, losing energy as expected, 3I Atlas did not. Its mean velocity remained unchanged, even as it passed through the sun's gravitational well. That should have been impossible. Any natural body near the sun must lose energy through radiation and sublimation. But 3I Atlas appeared to compensate, as though balancing its own energy budget from within. Borisov had been the messenger, a glimpse of distant chemistry. Atlas, arriving later, behaved like something else entirely, a self-regulating structure, responding and adjusting to its environment. When orbital data were finally refined, the trajectory of 3I Atlas formed a shape unlike any seen before, a long asymmetric S-curve, twisting gently before departing the ecliptic plane. No known physical model could reproduce it naturally. It looked, in a way, as if it had been drawn on purpose. Borisov came and went, leaving quiet data behind. Atlas, with every observation, left behind another question. It was not merely passing through the solar system, it was interacting with it, deliberate, rhythmic, and unnervingly consistent. When the final August data were logged, a researcher in Paris summed it up with a single line: 3I Atlas does not depart like a visitor. It moves as though it knows the way back. After months of data from ground observatories and orbital satellites, a new discovery silenced the scientific community. Not because it was too complex, but because it was too precise, too perfect to be dismissed as coincidence. Researchers noticed that every subtle variation in the orbit of 3I Atlas occurred exactly at the same moments. The object emitted its periodic bursts of energy. The same 33-minute cycle first recorded by TESS months earlier. At first, it was treated as chance alignment, but as datasets from Hubble, Gemini, and Earth-based radio arrays were synchronized, the correlation became mathematically absolute. Each time 3I Atlas entered a peak light phase, its orbital coordinates shifted by a minute, consistent amount, just enough to adjust its trajectory, as if its own light were steering its path. Such a phenomenon had never been recorded in astronomy. No natural object was known to maintain this level of precision between radiant emission and orbital motion. At ESA, scientists built a new model. They proposed that 3I Atlas might possess an internal energy feedback mechanism, a process in which outgoing radiation was subtly reabsorbed through its surrounding plasma shell, creating micro-corrections in angular momentum. In essence, it was balancing itself through the rhythm of its own light.